You've got big projects to tackle, but your day gets swallowed up by repetitive tasks and constant inquiries. It's hard to make progress when you're stuck putting out fires. That's where Element 451's AI assistants come in. Acting like an extra set of hands, you get your time back for the high-impact projects. Ready to reclaim your time? Visit element451.com/AI team to learn more.
Welcome to the Generation AI podcast, where we demystify artificial intelligence in the world of higher education. I am your host, JC Bonilla, joined by the insightful co-host, Ardis Kadiu. How you doing, pal?
Hey, JC, how's it going?
My friend, I'm doing great. Last week, we did an episode where the word synthetic data was mentioned 55 times. So we're coming today with synthetic data all the way, Ardis. So how am I doing? I feel like I need closure on synthetic data. How are you feeling?
Well, I love synthetic data. I've been fascinating with this topic now for the past couple of months. And the reason for that is because, I've always thought that we have a lot of data in our world and we're generating even more data. But in the world of AI, synthetic data, it's basically like lifeblood, right? It's like, you think about it this way: only a certain amount of the world's water is drinkable, right? And that's your real world data that you have. But you have, the oceans and all this. Now, if you think about synthetic data, it's very similar. It's like, how do we take, rules and systems and all of that stuff? How do we feed that to our AI system so they can learn all of the new things that we need? More data is always better. So sorry, thanks for letting me go on a little bit of a rant there, but I've been really, really fascinated about this idea of synthetic data, especially after I heard Jensen Huang talk about, he's the CEO of NVIDIA, and he had a side graph chat with Mark Zuckerberg and a few other kind of conversations that he had. He keeps mentioning this idea of simulations and simulations and simulations, and NVIDIA is building simulations. And I'm like, what the hell is he talking about? And then I realized, I'm like, holy shit, it's like simulations means that they're building real representations of the world, and they're collecting, synthetic data about everything. So you can simulate anything, and then you collecting information about that, and then now you can put that into AI models so they can learn how these things work. So a little bit of a long rant there, but thanks for agreeing to do an episode on synthetic data.
We just mentioned 55 times last week. 42 of them were you, and I just repeated the word 7 times, which allowed me to basically mention it 3 times by myself. So that's why we're doing it, because Ardis is fascinated with synthetic data. But look, everybody, understanding what synthetic data is, where does it come from, and how it gets used is fundamental. My application and why I found this to be fascinating, it's 2 forms. One is you and I together, Ardis, with Tonka. I remember how we needed to create our first synthetic data set. I called it Tonka as a play tool to basically get schools in our own machinery to fail and fail safely. So we need to create a data set for failure. But then, fast forward to 2024, did you know that ChatGPTs of the world, OpenAIs, and many of these algorithms literally have ran out of data to train? They've consumed everything there is. All the internet that there is, they basically consumed it, right? And it starts to think about, how do I generate more data to train? And this is where you start seeing commercial opportunities where they want to buy books and publishers, or maybe I start making my own data sets to either do simulations or start training my algorithms. So it's a really interesting, fascinating body of work, and has caught so much attention recently because the immense appetite for LLMs to consume and devour everything there is there. Let's start with an example, Ardis. Imagine you are a coffee shop owner, and I'm going to comment and say, I can give you a forecast of how many cups you need and beans and all kind of stuff. Show me your data. And you're going to come and tell me, what do you mean? I just go and I, put the espresso machine in the coffee. I don't have time to collect data. I was like, okay. So 10 years ago or 5 years ago, I would have walked away. Today, I have a new possibility. I would come and tell you, Ardis, but you know your clientele. Yeah, okay. So can you tell me when rush hours are? Can you tell me the typical product combinations? Can you tell me realistic prices and quantities? And all of a sudden, I can ask you 3 or 5 or 10 questions about the behavior in the production, the servicing of coffee. And guess what? You know that left out, right? Product combinations, you'll tell me, they always get a croissant. But oh my gosh, 7 to 9 is crazy. I barely, can keep up, and it's always Americanos. The people with latte and the oat milk, folk come in the afternoon, whatever. Those are the layers that can be algorithmically inputted into a layer of generate data, and uses all that to generate layers of data. Does that make sense, the example?
Yeah, it makes a lot of sense. So if you were to come in and say, Ardis, build me a model today, that can predict, the coffee shop traffic that can come through that coffee shop and kind of the forecast how much money I'm going to make. If I throw that today at a large language model, it probably hasn't seen that financial data from a coffee shop, so it doesn't understand how to produce it or how to mimic it, right? Or how to give me predictions on it, because he hasn't seen that before. But what you're saying is that we can produce synthetic data and then feed that synthetic data to a model, and then that model can then give us predictions. But the synthetic data comes from certain rules that we put together, right?
Exactly. So specifically, I need to generate 10,000 data points with 4 columns. The basically timestamp, date and time, the product, the quantity, and the price. And I'm going to say popular morning rush times are from 7:55 and 9:45. The typical combinations are coffee with pastry, and I have these 3 types of pastries, and the prices and the quantities that I kind of usually get. Give me 10,000 rows, and then boom, you have it. Giving you the ability to come and start doing inventory management, forecasting, and those type of things, right? And that's literally the simple application that we see on synthetic data.
Yeah, that's a very simple one. Yep.
So let's define Ardis. We've been talking about synthetic data, mentioned it a ton of times last week. What is it? I hope by now everyone understands that synthetic data is the artificially generated data that mimics the patterns of the real world. Specifically, it mimics the statistical properties. Oh yes, I love this, right? We're going to be looking at central tendency, dispersion, all that kind of stuff. And it will generate things that follow that distribution, right? And I can do this in large scale. I can say, give me 1,000 or 1,000,000,000,000 samples that have this statistical distribution. It's used to enrich machine learning, to train machine learning, or to take generative AI techniques to the next level, because we basically ran out of available data, right? Why does it matter? We've been talking about it. Generative AI is hungry for data. Specifically, there's a stat from Gartner, Ardis, that says that this year, 60% of the data in AI, it's synthetically generated. 60% of the data is synthetically generated.
Yeah, it's interesting.
It's fascinating. I really, it feels wrong that the majority of the data is synthetically generated.
We're seeing that, just to give you for example, we're seeing that today where GPT-4 and some of these frontier models are getting used by people to generate synthetic data in order to train smaller models or to train specific models. So this is a very, very common technique today where frontier models, because they're trained and they have this really large data sets, billions, trillions of parameters, they can generate synthetic data. And then now you can train a small model that is specific to a particular domain or a use case. They can be a lot smaller, a lot faster, a lot more accurate, being trained on that synthetic data. So that's a very common technique that's being used today.
It's so common that, one of the most progressive regulation bodies on AI, which is the EU, included in their AI Act of last year that synthetic data is basically available. In its acknowledgement means that it's something that could be regulated. Today, when you go to ChatGPT, it caught my eye. There's a disclaimer that do not feed or do not prompt with personal data because your prompts are subject for training. So in other words, training synthetic data can emerge from, hey, these are basically my costs or whatever personal information I provide, and it can be launched over there. Also, privacy and security is a really important point, right? So one of the things I can mimic, it's JC's lookalike. Knowing that there's one JC, I can generate 50 variations of it. And all of a sudden, I circumvent the important aspects and the constraints of privacy and security. And number 3, labeling data and generating training data is so expensive and slow. So the cost and time efficiency gains are incredible. I don't know if you remember early on when ChatGPT made its debut, there were a ton of interest on how they generated their safety labels. Because you can ask ChatGPT, build me a bomb, and it'll say no, I don't do that. Or how do I commit suicide? It had basically red flags of I don't do that. Where they came from? It was an outfit out in, I believe, in Kenya that specialized on labels, and the mental word and the implications of the mental health of all the humans who had to do the labeling were gigantic. Why? Because all of a sudden you're reading thousands of variations of suicide, bombs, or whatever is negative, that needs to be basically negative data, that it's already removed because synthetic data circumvents that.
Yep. So the mental health of all those workers that are working on that data, synthetic data essentially eliminates that problem because AI or these models can generate that synthetic data, and they can also label it appropriately if it's positive, negative, and so on and so forth.
Yeah. Benefits, of course, we get to train more data. We also get to do a lot of testing. One of the important things on the observed data is that I can come and say, let's create more edge cases. So remember the coffee shop example, that crazy producer who came and bought 50 lattes or, whatever, fancy lattes she wanted. I can come and test an algorithm with variations like that and understand what happens, which has a really interesting scenario that if I understand the limitations and the biases of my model, I can start doing bias reduction by oversampling the data that is not observed. So I do not have a lot of male Hispanics with an accent who are in academia and they have awesome hair. JC Bonilla, obviously. So give me 50,000 rows like that and I'm going to train against it. So bias reduction would basically be one of the things that gets benefited from it, no doubt.
Hey, it's Mallory. Element 451 is hosting the AI Engage Summit on October 29th and 30th. This free virtual event brings together leaders, innovators, and many of your favorite Enrollify creators to explore AI's impact on student engagement, enrollment marketing, and institutional success. We're packing the schedule with real examples and case studies, so you leave knowing how to harness AI to drive meaningful change at your institution. Whether you're looking to enhance student outcomes, optimize enrollment marketing, or simply stay ahead of the curve, the AI Engage Summit is your gateway to the next level of higher education innovation. Registration is free. Visit element451.com to save your spot. Now, back to the show.
I mean, we've kind of talked about, this is kind of a combination of, we need these models to mimic real world manifestations of either 3D spaces, like where we are. We only have certain amount of driving data. So for cars to essentially learn how to drive, they need a lot of data. For different to create new molecules, we need to synthesize and mimic and generate a lot of data for the systems to learn new components and so on and so forth. We need synthetic data to think about different specific systems like reasoning. It's like, well, there's not a lot of data in the world right now to understand how do you get from point A to point B. And how humans think one by step by step by step. There's not a lot of that data out there. And that's what we talked about last week. So we need these models to get better and better, but we needed to give specific data that is representative of the problems that we're trying to solve and the world that we're trying to mimic as part of this LLMs or as part of this large language models, the capabilities that we need to add to them. We just don't have enough examples in the real world of that. And the internet data that we have is very biased in a lot of different cases, right? So it's biased from the time that it was produced. It's biased based on who produced it. It's biased on social media and so on and so forth. So synthetic data gives us the opportunity to build a rule-based world and then generate data on that and then feed that data to train systems that are learning on clean, high-quality examples.
100%. So let me add a bit of color to these examples. Autonomous vehicles. Synthetic data today is being used to generate simulations of cars basically going into safety or precocious road conditions. In finance, fraud detection and anti-money laundering, all the risk management, what you start doing is creating this ridiculous, cartel, terrorist attacks taking place, whatever, and then your financial models taking place, right? In healthcare, it's fascinating because a lot of things that you could be doing here, it's protecting the patient's privacy, generating models that expand that way, right? And insurance artists, think about the edge cases that an insurance policy would, try to mimic, right? So if all of a sudden the house got flooded, right? But Sandy comes and all the houses got flooded, right? And then it was literally, breaking insurance to the next level. And in your world, software development, testing applications, using sensitive product launches and things of that sort. So beautiful applications and synthetic data being used to the next level. Anything to add before we go into one of the things I'm the most excited about today?
I think we've talked a lot about it. So let's go into your next segment.
My new segment. Everybody, we're launching something that Ardis in a way demonstrated, I think, about 6 episodes ago. And as you know, Ardis has an incredible ability to prompt. More formally, he has actually created prompting courses and has been doing a lot of formal education around prompting. So we are bringing you a new segment called Hey Ardis, I Have a Question, where literally Ardis and I will build an in situ, on-prem algo or result from a prompt that is a question that I haven't done it, and he hasn't done it. So it's a live iterative aspect of Ardis. How do I do this? So the section is called Ardis, I Have a Question, and specifically today, I have a question about synthetic data. Ardis, I need to develop a model for admissions. I know the number of students that are going to come. I know and they're going to matriculate and start. I know the specifics on genders and extracurricular things that they like. I also know their kind of averages in terms of GPAs, SAT scores. And there's this feeling about recession, there's this feeling about graduation rates and the political climate that I think is important. I just don't know how to do that. So do you think we can do a little bit of synthetic data exercise here?
Let's do it.
So Ardis, what we like you to generate for us is a synthetic data generator using some type of artifact, some type of output that is going to be biodemo sensitive, so 1 or 3 variables on biodemo data, academic, and something of a risk, something an externality. So where would you go to build this, given that what we want is some type of output, not only the synthetic data, the rows, but maybe the code to generate it over and over and over? Where would you go?
So the first place I would go is Claude, and I've already have a set created over here for us, so we don't have to necessarily, we can certainly do it live, but we can also take a look at kind of the output that we produced on this. So I'll go to Claude and I can ask it around being a synthetic data generator, and I'll ask it that it can help me generate higher education admissions and enrollment data so I can better model my class and enrollment.
How would you actually start the prompt? Because a lot of the things that happens in prompting is I go, give me the data, but I found you in your courses, in your basically approach, you always define the expertise. You're an admissions expert. How do you start the prompt?
In this case, I just picked a random name, and you said you're a synthetic data generator. You will help me generate higher education admission and enrollment data so I can better model my classes and enrollment.
Okay.
So I'm providing it more context in there.
And what I see on the screen, once you do that prompt, actually gives you a whole, I would say, recommendations of how to start building the next steps in the prompt, such as, all right, what is specific school do you want? What's the scale? So it gives you about 4 different things that refine the prompt to a better output. All right. What I love to do is give me a 60-40 gender split. Let's go very, 1990s men versus women. I'm going to assume this is a kind of selective tier 1 engineering school. So mostly men, 60-40, because it's tier 1, GPA is above 3.5, very high math SATs. What else? And we wanted to make it demanding and selective. How would you prompt that?
So we can actually just tell it. So generate biodemo data, the age and gender with 60% men. So let's actually recreate that process right now. So generate biodemo, age and gender, columns with 60% men, academic data, GPA above 3.5, and SAT high quant math. We're going in and saying, give me also the application term in there. We're then talking a little bit more about the tier 1 engineering school. It's for tier 1 engineering schools. And then the time period as well. We want it to be kind of one period of recruiting.
I like that. So you're generating all that with a 1 year, and you're defining the output as tabular. Okay. All right. So run this. What happens?
Yeah. So we're running it right now. So what it's actually doing, it's producing for us a Python code. So, and then what it's telling us, it's that it's saying, hey, copy this script into some Python notebook, but we can say, can you create an artifact that will actually showcase this data? So let's see what it does.
So the first output is Python code that allows replicability, so that this gives you your, I guess you bring it into a Python environment, notebook and whatnot, and then you can generate these 1,000 rows. You can change the parameters and make it more extensive. Love it. And what other artifacts did we get?
Well, it's basically trying to put an HTML page together for us. And if you remember, one of the things, sometimes it does it well, sometimes it doesn't, but you can come back and you say, I got this error. And in this case, it didn't actually render it correctly because it used a different library. So we can come back and say, hey, rewrite it again. So it's rewriting it as a specific output for us.
So I'm getting a visualization with the synthetic data that we requested and some type of summary of the first rows. Ardis, this is synthetic data, and it has 1,000 application distribution. It ended up with 58.5. The average GPA is 3.7 and an average SAT math of 7.55. Very interesting. And I like how it's given the application by term visual, and it's actually projecting a decay of term to term over the year, right? So fall being the biggest one, spring 2025, and summer 25 with slightly smaller number of applications. Fascinating.
Yeah. If we have a little bit more time, we can certainly create some more artifacts, or, that's why they call them artifacts in here, but we can certainly kind of create some more dashboarding and some data around, hey, can you help me? Can you actually show all of the applicants rather than just the first 10? Or can you give me some UI to manipulate the gender, so you can do some simulations, right? So if you simulate how many male versus female applicants you have, you can regenerate the other data as well. So the idea here for doing this is these LLMs are really, really good at generating data. You can provide specifically what are the rows and what are the columns that you want. For our purposes, because we kind of did it a little bit freestyle, it would take a little bit longer to kind of think through like the specific rows and columns. We still did a pretty good job, within within 5 minutes. However, you can see how powerful this can be for generating that synthetic data.
Love that, Ardis. Thanks for walking us through this, and specifically everybody listening, as we walk you through the steps of synthetic data, what it is, the benefits. What you hopefully see is how tangible and accessible it is today. That's what we're talking about, it, right? And within 5 minutes, as Ardis said, we generated a synthetic data set that could be used for simulating financial aid, admissibility, likelihood of having the right class, and multiple use cases. So there you have it. And I hope you enjoy the conversation about synthetic data, where this is going and how you benefit from it. Ardis, any parting thoughts?
No, this is a great topic, JC, and thanks for kind of doing a more interactive episode this time.
You got it. I hope you also like Ardis. I have a question. We'll bring this here and there. And again, it's an opportunity for us to start getting more tangible, more interactive, and bringing results of where journeys of AI are basically bringing the practice, our thinking, and, interesting questions. So here we are. Remember, subscribe, follow us. And if you have any questions, send us your comments. We'd love to hear from you. Thank you, everybody, and we'll see you soon over podcasts.
Till next time. Generation AI is part of the Enrollify podcast network. If you like this podcast, chances are you're going to like other Enrollify shows too. Our podcast network is growing weekly, and we've got a wide range of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional. Our shows help higher ed leaders and professionals like you find their next big idea. They feature a selection of the industry's best as your hosts, like Jamie Hunt, Seth Odell, Jenny Lee Fowler, Brian Gross, and many of your favorite leaders in higher ed. Enrollify is made possible by Element 451, the next generation AI student engagement platform that's helping institutions all over the country create meaningful, personalized, and engaging connections with their prospects and students. Learn more at element451.com.